Good afternoon. My name is Stan Duda and I'm the National Sales Manager for ITW Opto Diode. And I'm here to introduce to you our newest product. Opto Diode Corporation, a division of ITW, is pleased to announce the industry's first EUV compatible position sensing detector, or PSD, for the position measurement of deep UV and EUV light or detection of light. The PSD is optimized for use in the 0.1 nanometer to 400 nanometer spectral range. The PSD is a two-axis continuous position sensing device which is able to continuously resolve the position of 13.5 nanometer beams based on the dual lateral charge division principle, yielding sub-micron position resolution. The device has a top N and rear P resistive layers which determine the beam's X and Y position. When a light beam hits the active area or the top N layer, electron hole pairs are generated proportional to the light intensity. Electrons are collected by the electrodes as a photocurrent, the amount of which is proportional to the inverse electrode distance from the light spot. The whole current is collected by the rear electrodes. Because signal is collected from the electrons as well as holes, dual lateral devices produce currents twice as large as the tetralateral position sensing devices, which have all four electrodes on one side of the detector. This doubling results in twice the position resolution, leading to sub-micron beam position resolution. The light spot position is determined by the four photocurrents that are measured. The beam position obtained is simply the beam centroid and thus does not depend on the beam shape or size or intensity. The beam centroid position from the center is obtained using 300 micron wide 13.5 nanometer beams. The PSD exhibits excellent responsivity and stability, virtually with no loss in responsivity after receiving a total energy density of 2.94 millijoules per centimeter square from a 244 nanometer CW laser. The responsivity of the PSD is not affected by exposure to billions of 193 nanometer and 157 nanometer excimer laser pulses with 100 microjoules per centimeter square pulse energy. The observed capacitance versus voltage behavior is consistent with that of the abrupt one-sided PN junction diode. Temperature dependence of the dark current indicates that the dark current doubles for every 7.5 degrees C rise in temperature. The temperature dependence of the photodiode responsivity at 2.54 nanometer was found to increase by 0.03% degrees Celsius. It is known that the front silicon dioxide window in standard photodiodes causes changes in the photodiode responsivity after exposure to intense UV, EUV photons. Unparalleled radiation hardness in the SXUV device is achieved by replacing the SiO2 window with a nitride non-oxide window, thus eliminating UV, EUV exposure-induced instability problems. The absence of the front silicon dioxide passivating layer leads to significant surface recombination in the SXUV series diodes. This surface recombination causes the significant loss in the responsivity for photons, which are strongly absorbed in silicon. When tested using a beam at around 13.5 nanometer, responsivity of this device was found to be within plus or minus 1% of the measurement uncertainty after exposure to a total dose of 220 kilojoules per centimeter square. When tested using a synchrotron with light around 13.5 nanometer, responsivity of this device was found to be within plus or minus 2% the measurement uncertainty after exposure to a total dose of 240 kilojoules per centimeter square. The key features of the PSD are sub-micron position resolution, stable response after exposure to UV and EUV, a large 5x5 millimeter active area, an industry standard T08 windowless package, low dark current at roughly 10 nanoamps typical at 30 volts, low capacitance 40 picofarads at 30 volts, and a shunt resistance minimum of 5 megohms at 10 millivolts. Because of their unparalleled responsivity, these devices will have many applications in UV, EUV sources, and are suitable for applications in beam position monitoring, in EUV scanners, and inspection tools. To learn more about this exciting new product, please contact your local sales rep, or please go to the Opto Diode website at www.optodiode.com. Thank you for your time.